But even more exciting is that the National Task Force for Teacher Education in Physics is here to continue to work on the task force report. And so today we're just going to give you a rundown on what we found and who we are. So let me just, I'll just introduce everybody. You know who I am, Valerie Otero, and University of Colorado Boulder, one of the task force members. Do you want to just introduce yourself?
I'm David Meltzer from Arizona State University.
Stamatis Vokos from Seattle Pacific University.
I'm Monica Plish from the American Physical Society.
And we're just going to go through and give you a sense of what we found. And this is a case from physics teacher preparation. We assume that it's very similar in other hard-to-staff areas, such as chemistry and math, most likely. So here's what we found.
And should I go ahead and pass these on?
Yeah, and we've got some synopses.
I think we have a copy for almost for everybody who's here. So if you really don't want one, don't take one. And sorry, we're down to our last copies here. So
which is a
we
good,
know how to share.
which is a good thing because after the work of the last 8 hours, the phrasing of some of the recommendations has changed. And
so these are the last of the first phrasing of the recommendations, which we just did a job on over the last 8 hours, as Stamatis points out. So Stamatis will be giving the presentation as the chair of the committee, but I think we'll all be chiming in throughout.
Yes, absolutely. And so this will be really boring if this is just a talk or even 4 people sort of droning on. And so it would be important to sort of make this as relevant as possible to the local context. One of the things that I can tell you in advance, that you will see what a great place CU Boulder is. I mean, as if you needed reasons to justify that. So the talk is going to have 5 sections. One is context for pre-college education. The second one is the task force charge that responded to the national crisis. The third one is the methodology section of the work of the task force. And then we're going to talk about the findings and the recommendations. So I will start. Although I think that Valerie actually does the best job in actually setting the stage for the national crisis in education. Do you want to do this?
I wonder what's in those slides. Do we know?
I don't even know
these slides. Okay, let's see what I'm going to talk about. This is new, but it's not new. So as you know, there is a crisis in mathematics and science education. I think most of this group is very aware of that. In fact, Secretary of Education Arne Duncan has said that teacher preparation programs should be among a university's most important responsibilities, and that education is the civil rights issue of today. We look at progress on the National Assessment for Educational Progress. For example, in 8th grade in 1996, 2000, and 2005, and you see here in science, there has been no change, regardless of all of the input that's been put into course reform. And I think what's interesting here is if you look at 2005, about 29% of 8th graders were scoring proficient or above, and only 3% were scoring at advanced. What's more interesting is when we look at the 12th grade NAEP scores, we see that there's actually a decrease, a decline in scores over time. But more interesting is only 16% of the students are scoring proficient or above. Take-home message is that the situation gets worse as students move through our system. They're doing more, the fewer are scoring proficient in 12th grade than in 8th grade. And that shows kind of a snapshot of what's happening to our students in our system. We can look at the TIMSS, the third International Mathematics and Science Study, and find out that of the countries that are scoring worse than the United States in advanced physics, there are 0. There are none scoring worse than the United States in advanced physics. And then we can...
When they say advanced physics, what does that mean?
Like AP physics.
And IB.
NIV.
But that's not quantum mechanics. That's just.
It's
Right.
yeah, it's AP and
So you
and
can't
national
have
level.
quantum in
Yes.
high school physics.
And then, you know, this shouldn't surprise us too much when we see that about 2/3 of the people that are teaching physics right now have neither a major or a minor in physics or physics education. And there's a critical shortage. We need about 1,200 physics teachers per year, and we're getting about 400. And we know that about 30 to 40% are leaving within the first 5 years. So there were 10 priority recommendations, as you guys all know, that were made in congressional charge in 2005, and only 4. They were asked to make 10 in order for the United States to be competitive in the 21st century. This group made 4 recommendations, the first of which is to increase the number and quality of mathematics and science teachers. The second, to increase basically undergraduate STEM majors. That's number 3, and to enhance science and engineering research. In 2007, there was a public law that was passed to move funds into this area. So while we're not the only ones that are interested in understanding that there's a major crisis in STEM education, and there are monies being put into it, as you all know by looking at most of the media today, we decided to take a look at what is going on in physics teacher preparation. And we convened a task force made up of people that Stamatis will talk about in order to find out what is going on in the preparation of physics teachers throughout the nation.
So the professional societies in physics were absolutely instrumental in actually bringing, constituting the task force. And here's the task force charge. We were tasked with identifying generalizable strategies to increase the number and improve the quality of physics teachers. The shortage of physics teachers is a very easy message that captures the national imagination, right? We need 3 times as many qualified teachers than we actually produce. However, among the task force members and members of the professional societies ourselves, we did not want to just produce more teachers, but we wanted to concentrate on what constitutes high quality preparation of physics teachers. And we were tasked with articulating research policy and funding implications, and to develop a strategy for initial dissemination of results. The synopsis that you see was unveiled last February at the joint American Physical Society and American Association of Physics Teachers meeting in Washington, D.C. And the final report is going to be coming out within the next couple of months. That report is going to be circulated to all physics departments and all schools of education. There are relevant recommendations for the physics education research community. There are relevant recommendations to funding agencies, public and private funding agencies, as well as policymakers at the national and state level. So the TTEP members come from a variety of different backgrounds. So we had physics folks, we have teacher education folks, we have school of education folks, we had deans, we had provost, we have members of the professional societies, we also have teachers, and we tried to look at the totality of the evidence over there so that we can speak to this issue. There were lots of additional people who actually have contributed thus far to the work. These are folks who either provided feedback to some initial work of the task force, or came with members of the task force to site visits that the task force conducted. So, Monica, would you like to talk a little bit about the data collection?
Sure.
We've never done this before, not knowing what slides are going to pop up in Stamatis' computer.
Okay. So one of the first things we realized that was important to do was to just get some basic numbers in terms of who is educating physics teachers, how many physics teachers are being educated, where are they being educated. So we did a number of things. We attempted to get information from state education departments, which was tough. We called all 50 states in the District of Columbia. In the end, we got usable data only from about 18 states. And we were asking, so how many physics teachers has your state certified by institution, according to the program that they went through? And the numbers varied quite a bit. We also worked with the American Association of the Colleges of Teacher Education, and they generously shared with us data. So they have about 700 members or so, and their members report how many physics teachers, et cetera, they graduate from their programs. So we got that data. We worked with the American Institute of Physics Statistical Research Center, and we surveyed all 754 physics departments. Got a very good response rate, actually 77%, to ask them about their engagement in physics teacher education. So we asked them things like, do you have a track, concentration, or specialization intended for future physics teachers? And then asked them other questions about, who can we talk to? If you want to do a follow-up, who's the person who's most knowledgeable about your program? And we actually did a follow-up interview with about 30 institutions. We selected those institutions that were graduating 2 or more physics teachers per year on average. That doesn't sound like a lot, but in fact, the numbers is somewhere between 30 and 40. So that was, you can already see this is kind of leading up to one of our first major findings.
In other words, we talked to all that were graduating with that many, all of them.
A very large fraction. I think over 80%, I would say.
More than that.
Yeah, 80 to 90%. And then the third thing that we did is we did site visits to about a dozen programs that we identified as thriving programs in physics teacher education. So we sent email to all physics chairs. We also sent a letter to schools of education, basically asking them to nominate themselves and supplying some information. Asking them to nominate themselves as exemplary programs. And then we had a site selection committee that kind of went through the list and looked at all institutions that are graduating 2 or more physics teachers per year, and aimed for a distribution geographically as well as different types of institutions, R1s, comprehensives, things like that. And then this map just shows the geographical distribution as well as the names of all the institutions that we visited. So for our site visit teams, we had 3 people, typically task force member, professional society member, and then somebody else who was knowledgeable about teacher preparation. And reports on each of these institutions is going to appear in the final task force report, and you'll notice CU Boulder was one of the places that we visited. Okay.
Quiz.
Not sure what's next. There's a quiz.
What's the quiz?
I think the quiz is it's something that you should ask. Yeah.
Oh,
This is
quiz! There's a quiz! So, 44 mathematics and science majors. These are high-achieving mathematics and science majors, undergraduates. Were asked, what would your professor in your major department say if you told them that you wanted to be a high school teacher? I need you to take a moment, talk with your friends, somebody next to you, and figure out what you think these students might have said. Take a moment.
Go to grad school?
Yeah.
But you're so much better.
Really?
Yeah.
We're potentially going to get an answer.
Unless you're the lower students.
Yeah, okay.
Yeah, I think we have.
You can fall back on that if you would. I would. I mean, that's part of the, well, it's not really the reason why I want to do it, but
Why waste your skills?
you could have a better, an easier
Something
job,
along those lines.
or...
Yeah, sadly.
How many of them said positive?
Yeah.
Every other 44.
Yeah, I guess in that not a whole lot.
Yeah.
I think that the professor would say.
Okay, so
Sure.
Yeah.
Encourage them to pursue your dream.
Exactly.
I'll give you an answer.
We need people like you to do this stuff.
Yeah.